Okay, we're going to take a look at some information about similar triangles and slope and how they connect. So let's take a look at the top portion of our notes and focus on similar triangles. This should be something that you have heard of before, but if you don't remember or you haven't heard or learned about similar triangles, you will now. So similar triangles are proportional to each other. What that means is corresponding sides are proportionate. Okay, and for corresponding sides, basically what that means is if you have the longest side coordinates with the longest side over here. So those two sides would be corresponding. In this case, it's a right triangle. So this leg corresponds to this leg. This leg corresponds to this leg. So if I were to give these triangles side lengths, for example, this side length was 2, and this side length was 3, and this side length was 4, and this side length was 6. I could take the corresponding sides, put them into a ratio, and they would end up equaling each other. For example, if I took the longer side and the shorter side and made a ratio, I would get 3/2. If these triangles are similar, then if I take these sides and put them into a proportion or a ratio, it would have to equal 3/2. Longer side over shorter side should equal longer side over shorter side. Now if I took 6/4 and simplified it, it becomes 3/2. Because my side lengths are proportionate, those triangles would be called similar. Okay, let's review a little bit about finding the slope with a triangle. It says the slope of a line is the ratio between the rise and the run, which we know is true. So let's take a look at this line we have right here. And I'm actually going to take that rise over run that you learned about. I'm just going to make the triangle for a second. I'm not going to worry about a rise and a run yet. I'm just going to look at the triangle. Then I'm going to make a second triangle. Now remember, when we draw these slope triangles, you always want to make sure that you're using horizontal and vertical lines, no diagonals. And you want your triangles to begin and end where grid marks cross. Okay, so you should end up with right triangles every single time. Imagine it's like you're trying to get from one point to the next, like this is your house and this is your friend's house, and you can't cut through the backyard, you have to go on streets. So you would walk down this street and then up this street to get to your friend's house. Okay. Now if we look at the rise and the run of these triangles, let's see what happens. So my green triangle here, my rise would be -1. My run would be -2. Down 1, backward 2. My pink line, my rise would be down 2 and backward 1, 2, 3, 4. Since I'm going backward 4, would be -4. So now if I take my rise and run and write it as a fraction or a proportion, my green line was -1 over -2, which would simplify to 1/2. And my pink triangle, the rise was -2, the run was -4. And that's going to simplify to 1/2. And we know these equal each other. So what's happening here is my corresponding sides are proportional. This side is proportional to this side. This long side is proportional to this short side. And based on what we did up above, we see that these are similar triangles. The other thing we can see is that we were able to create similar triangles, and this original line here is a side that they have in common. And that'll bring us to the next part. Similar triangles and slope, the rule. So our rule is right triangles whose hypotenuse, we'll talk about that word in a second, lie on the same line are similar triangles. So right triangles whose hypotenuse lie on the same line are similar triangles. So let me draw a picture of a right triangle so I can give you a little vocabulary here. Okay, so we know a right triangle has a right angle. Now the side across from the right angle is the hypotenuse. It's that long side. And if you look back up to the second section here, there's our right angle, and the hypotenuse is the side across. So this line, the triangles have the hypotenuse on this line. So anytime you're able to do these various slope triangles, you're creating similar triangles. So now we're going to do a little practice with our similar triangles. I'm going to take a look at this situation first. It says, draw another triangle with the same slope using a proportion from the legs of the triangles. Prove if the triangles are similar or not. Okay, that's a lot happening there. So when it says draw another triangle, which leads you to believe there's already a triangle here, which there is. So this is the original triangle that we're talking about. And we know it's a right triangle. You can even just look at the grid marks and see that it's a right triangle. So we're going to draw another triangle with the same slope. Well, based on the rule that we have, that we just talked about, my triangle will have the same slope as long as this hypotenuse, or the long side, they have in common. So pick a point. See how this point crosses the grid marks? You could pick a point here, or you could pick a point here, either one of these two. And I'm going to create a triangle. It's like a rise and a run. So we'll do our rise and our run. That makes a right triangle. So basically we're drawing two right triangles. And it says use the slope from the legs of the triangles to prove that they are similar or not. So we're going to use the slope and the legs to help us decide. So what that means is, let's find the rise and the run for each of the triangles. So for my pink triangle, my rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going down. So -9 is my rise. My run, I'm going backwards 1, 2, 3, 4, 5, 6. And then if I take my green triangle, my rise is down 1, 2, 3, 4, 5, 6. And my run is backward 1, 2, 3, 4. So it's -4. Remember, I'm going down and backward. That's why we're looking at negative numbers. So in the prove it section, what we're going to do is we're going to take our rise and our run for each, and we're going to see if they're proportionate. If they are, then the triangles are similar. So my first triangle, my rise is -9, my run is -6. If I simplify that, I can divide each by 3. I get 3 over 2, and it's positive because I have a negative divided by a negative. So a negative divided by negative is positive. If I take my blue, rise is -6, run is -4. Simplify, I can divide each by 2, and I get 3 over 2. They're both negative. Negative divided by negative is positive. So because 3 over 2 equals 3 over 2. Let's do another. Draw another triangle with the same slope using a proportion or slope from the legs of the triangles to prove they are similar or not. So I want to create similar triangles. So I'm going to just draw the triangle they already gave me. And then I'm going to draw a second triangle. Now my second triangle could be right here. My second triangle could be right here. It can be anything. I would just suggest that you choose one of these points that goes through the grid lines, just like you would do if you were trying to find your rise or run. So you have a lot of options of what to choose to make your second triangle. You can pick the one I pick. You can pick a different one. No matter what you pick, we'll see if you get the same thing. And there's my right angle. Okay, so over run. For the pink, it's down 1, 2, 3, 4, 5, 6, 7. My run is backwards 1, 2, 3, 4, 5, 6, 7. For the green, I'm going to rise over run. My rise is 1, 2 down, so it's -2. My run is 1, 2 to the left, so that's -2. Now in the prove it section, that's where we're going to take our rise over run for each and see what happens. If they're equal, then that means that these hypotenuse have the same slope. So -7 over -7 simplifies to 1. -2 over -2 also simplifies to 1. That checks out. They are similar. Now the last two you're going to do on your own, but I'm going to help you get started with the third one. Same type of situation. You're going to draw two slope triangles here. Okay, making sure that this line is the hypotenuse of your triangle. Sounds a lot harder than it really is. All we want to do is we're going to pick a spot where my grid lines cross, and you're going to try to find the slope is basically what we're doing. So you're going to pick 2 points. You don't have to pick mine. You could just watch for a second before you try on your own. But I'm going to pick 2 points. I'm going to make a triangle. And then I'm going to pick 2 other points. It doesn't matter which part you pick, as long as you pick a point where my line crosses grid marks. I could pick this for my triangle. Okay, basically you're trying to get from one point to the next by only going horizontal and vertical. So that's what I would pick. Maybe you would pick this little one. Maybe you would pick a really big one. But if you notice, because across from any right angle that you have, all these hypotenuse, they all are on the same line, which means they should have the same slope. So you'll pick your two triangles, and then down below you'll find the rise and the run of each and see if they simplify to become equal proportions. And if they do, then your triangles are similar. So you're going to finish this one and number 4 on your own, and that's it.